Hello everyone. Today we'll talk about the number system. Number system is a set of values that are used to represent quantities which are extensively used by the people all over the globe. So, in other words, number systems helps to represent a set of numbers in unique or standard manner based on the use cases. What are the different types of number system? There are four types of number system primarily. The first one is the most commonly used one, that is a decimal system. Decimal system has 10 sets of values ranging from 0 to 9. So if you see 0 to 9 are all the unique values, all the unique symbols. But after 9, that is 10, 12, 13, 11, these kind of numbers are combinations of two symbols. So to uniquely identify, we set out the decimal system of 0 to 9. Now if you count 0 to 9 in your hand, you will see that there are 10 numbers only. So deci means 10. Now binary means which has the two sets of values. Bi means 2. Now the two sets of values are 0 and 1 only. Why we consider this? Take an example of a switch. If a switch is turned off, it represents 0 because the current is not flowing. Now if the switch is turned on, the current is flowing, we say it as 1. So binary systems are commonly used in machines. Octal. So octal means oct means 8. So 8 sets of values. So if you count in your hand 0 to 7, there are 8 sets of numbers. Then the last thing is that hexadecimal. Hexadecimal has 16 sets of values. 0 to f. Why f? 0 to 9 represents 10 values, but after 10 we have to represent the 6 more values. We represent them as alphabets. So A means 10, B means 11, C means 12, D means 13, E means 14, and F means 15. So how a number is defined? We define a number with the help of phase and positions. So what is a phase value? The phase value is a number which you will see, which is the individual numbers in a set of number. So let us suppose 87. So 8 and 7 are the two phase values. But what are the positions? The positions represent the place where they are placed right now. So 87. So see, 87 is placed at the 0th position. Why 0? We start counting from 0. That is why 7 is at the 0th position and 8 is at the 1st position. So let us see how do we define that. So let's take an example of 743. So 743 is equals to 7 into 100 plus 4 into 10 plus 3 into 1. So but we represent them in the form of power. See, 7 into 100. So 100 has how many zeros? 100 has 2 zeros. So we will write like this: 7 into 10 to the power of 2 plus 4 into 10. So 10 has how many zeros? 1 zero. That is power is 1 plus 3 into 10 to the power of 0. So 1 has how many zeros? There are zeros. There are no zeros. That is why we write as 10 to the power of 0. And remember, any number to the power of 0 is 0. So if you consider the number 4 in the value of 743, 4 is the phase value and the position is 1. Number system representation. So this is the table which shows the representation of number system across all the different types of number systems available. So we have written in the first column that 0 to 15. So 0, as you can see in the table, is its representation in the binary form, any subsequent representation in the octal form, and any subsequent representation in the hexadecimal form. Let's start with the decimal and hexadecimal. So 0 to 9 is, you can see in the table, 0 to 9 is same, but after 10, but beginning with the 10, so A stands for 10, B stands for 11, C stands for 12, D stands for 13, E stands for 14, F stands for 15, and then come to the octal part. So here you will see 0 to 7 is same, but beginning with 8 we write the repetition part. So 1 0 means 8, 1 1 means 9, 1 2 means 10, and so on and so forth. And the last part is binary. We will talk about in the next video, not in the next video, in the next slide, where we will see that how we are converting this thing. So we will be seeing how to convert a decimal number to a binary number. So let us take a number of, suppose 87. So how to do this? We will do the LCM part with just a value of 2. So if you divide 87, so what you will get? So 87 divided by 2 is 43. So the question part is 43, because 2 into 43 is 86. So what is the remainder? 1. Okay. Again, divide 43 by 20 divide by 2. What we will get? 2 21s are 42. What is the remainder? 1. Again, 2 10s are 20. What is the remainder? 1. 2 5s are 10. What is the remainder? 0. Again, 2 2s are 4. What is the remainder? 1. Again, divide 2. 2 1s are, so 1 is the quotient and 0 is the remainder. So how do you write this? We write like this, from bottom to top. So 1 0 1 0 1 1 1, and we give a bracket and write in the lower part as 2. The 2 indicates it's a binary number. Let us look at some other examples. 142. So you can pause the video here and do it yourself, and then make sure that is right. So pause the video here and do it. So hopefully you have done the part. So let's see if your answer is correct. 271s are 42. So 0 remainder is 0. 235s are 70. So remainder is 1. 2 17s are 34. So remainder is 1. 2 8s are 16. So remainder is 1. 2 2s are 4. So remainder is 0. 2 2s are 4. So remainder is 0. 2 1s are 2. So remainder is 0. So is your answer correct? Let's see. 1 1 0 0 0 1 0 0 0, then 1 1 1 1 1 1, then 0. Hopefully your answer is correct. So let us move on the second part. Now let us consider a fractional decimal value. Suppose it is 125.624. So this is a fractional value with point in the middle. So let us do this. So how we will approach this problem? We will split this and split this, the decimal part, the rest of the part. So first the value before the point, so 125. So 262 is 124, so remainder is 1. 231 is 62, so remainder is 0. 215 is 30, so remainder is 1. 2 7s are 14, so remainder is 1. 2 3s are 6, so remainder is 1. 2 1s are 2, so remainder is again 1. So what do we get? 1 1 1 1 1 1 1 1. So 1 2 3 4 5. So 1 2 3 4 5 and 0 1. Now the rest of the part. Now let's talk about this part. There is a point 6.25. So point 6.25. So how do we convert this? We multiply it with 2. So let's multiply. 0.625 becomes 1.250. So let's take out this part. So it is 1. Then the rest of the part 0.250. Again multiplied by 2. So we get 0.500. So where is the phase value? This phase value is 0. So let's put this here. Again the remaining part 0.5 into 2. So this is 1.00. So it's 1. So there are no values left here. So we can write this from the top to bottom. So what do we get here? This here and here we get 0.101. So let's join these two parts. So 1 1 1. So 1 2 3 4 5. 1 2 3 4 5. The rest of 0 1 and let's join this part 0 1 0 1. So this is a representation of this to this. Now let's convert decimal to binary. We already done that. Now we will do the reverse one. Binary to decimal. Let us take an example 1001. Okay. So this is a binary value. So let us mark the positions so that it will be easier to calculate. So there is a 0th position, there is a first position, second, third, fourth. So we will do this from left to right. Sorry, right to left. Right to left. So let's take the first value 1. Since we are converting from binary to decimal, so the base of binary is 2 and the position is 4 plus second value is 0, then the base, then the position plus value base position, then value base position, then value base position. So what is the value of 2 to the power of 4? If you multiply 2 4 times, like 2 into 2 into 2 into 2, so 2 2s are, so we can write like this 2 into 2 into 2 into 2, okay, plus 0. So we will not consider this part because it is already 0, so let it be like that, 0 again. Then we will write like this 1. Since its power is 1, so we will write just one time, and again we will not consider this first because this is 0. So how much it is? 2 2s are 4, 4 2s are 8, 8 2s are 16. Then the 0 plus 0 plus 1 2s are 2 plus 0. So if you add all up, you will get 18. Let us look at some other example. Suppose 1 0 1 1 1 1 0. So how do we convert this? So count like this 0 1 2 3 4 5. So 1 first value. How many? What is the position? 0 1 2 3 4 5. So 2 to the power 5 plus 0. What is the position? 0 0 1 2 3 4. Then again 1. What is the position? 0 1 2 3. What is the position of second one? The other value is 0, 1, 2. Yes. Again 1. So what is this? 0, 1. 2 to the 1. 2 to the power of 1. And again, what is the position? The 0th position to 0. So if you multiply it to 5 times, what will be the answer? So 1 into 2 into 2 to 2 into 2. So it is 4 2 and again. So then we will part, since 0 anything multiplied by 0 is 0, so let it be like this. Again 1 to 2 into 2 into 2. Okay. Plus 1 into 2 into 2. So here 2 values 4 because 0 and 2 plus 1 into 2. So anything multiplied by 0 is 0. So let it be like this. So it is 32. Little 0. Then 8. Then 4. And 2. And 0. Let's add it all up. 32 plus 8, 40. 40 plus 4, 44. 44 plus 2 is 46. So result is equivalent. Now let us see how to convert a fractional binary value to a fractional decimal value. So let us take an example. 0 1 1 1 1 dot 1 1 1 0. Okay. So how do you write this? So look here, we will go from left to right, right to left, and here we will go from left to right. So we will write like this. 0. The positions are 0, 1, 2, 3, 4. Okay. Now if you write the positions for the decimal part, what will be that? 1, 2, 3, 4. Alright. Now how to convert this? This is 1 as it is. We will write this first. 1 and 2 to the power of 4. This is a position. Again 0 into 2 to the power of 3 plus 1 into 2 to the power of 2, 1 into 2 to the power of 1 plus 1 into 2 to the power of 0. Alright. Then so you have already 1 0 1 1 1 done. Now the rest of the part, this one. So how do you do that? So we do this like this. 1 2 2 to the power of minus 1 plus 2, not 2, sorry, this is a value of 1 and the position is 2, so minus 2 plus 1 into 2 to the power of position 3 minus 3 plus value 0, 0 into 4 to the power of 2 to the power of minus 4. So we can add another value. Suppose we add another line, another one, so it becomes 5. So plus 1 into 2 to the power of minus 5. So let us see what are the values are there. So 2 to the power of 4 is 16. We will not consider the 0 part. So 0 to the power of 2 is 4. To the power of 1 is 2 and to the power of 0 is 1. Remember, anything to the power of 0 is 1. So 1 into 1 is 1 plus this minus means 1 by 2 to the 1 by 2 plus, again since it is 1 we will consider this 1 to the power 2 plus, again 1 to the power of 3. So since here is 0, so we'll not consider this part, so we'll put just 0 here, and this part 1 to the power of 5. So what is output? So let's add it up. 16 plus 4 plus 2 plus 1, what is the answer? 16 plus 4 is 20, 20 plus 2 is 22, 22 plus 3 is 23. Now 1 by 2 is 0.5, 1 by 2 to the power of 2 is 0.25, 1 by 2 to the power of 3 is 0.125, and this part is 0, just keep it like that, and this part. So 1 by 2 to the power of 5 is means 1 by 32. So 1 by 32 is, so this 1 by 2 is 0.5. So 1 by 2 to the power of 4 is means 1 by 4, so 0.25. 1 by 2 to the power of 3 means 1 divided by 8. So 1 divided by 8, if you do that in your rough side, you will get 0.125 plus, let's erase this because we will not consider this part, plus 1 and 2 to the power of minus 5, so 1 by 32. So if you divide 1 by 32, what will you get? We will get 0.03125. Then let's add it up all. So what we will get? So we are getting from this addition 0.90625. So resultant output is 23.90625.